The ShinyItemAnalysis (SIA-R) package is a versatile tool for analyzing multi-item measurements in psychology, education, and social sciences. It offers an interactive platform with various psychometric tools. A new feature introduced in the recent version of the package, called SIAmodules, allows researchers and practitioners to offer new analytical methods for broader use via add-on extensions. These modules can integrate with and build upon the SIA interactive application, leveraging the existing infrastructure for tasks such as data uploading and processing. They can access a range of outputs from various analyses, including item response theory models, exploratory factor analysis, or differential item functioning models. The SIA modules are designed to be distributed as R packages, which may come bundled with their datasets, use object-oriented systems, or even compiled code. This concept has the potential for broader use in other areas beyond social sciences. The ShinyItemAnalysis (SIA) application provides an intuitive entry point for newcomers to R, offering access to sample datasets and the ability to upload and analyze data. Structured according to the standards for educational and psychological testing, the application outlines a workflow that facilitates moving from a graphical user interface to the command line interface of R, enabling automation and ensuring reproducibility. The SIA application incorporates sample R code, leveraging functions from ShinyItemAnalysis and standard psychometric packages such as MERT, Psych, and DIFR. This integration generates PDF and HTML reports, aiding in the incorporation of psychometric analyses into the test development process. The interactive environment of SIA has the potential to facilitate teaching psychometric methods and concepts, supporting the implementation of psychometric methods in R and expanding their reach to broader audiences. To enable users to extend the analyses and functionalities of the SIA application, the SIAmodules feature is introduced. This feature allows researchers and practitioners to develop add-on SIA modules that seamlessly integrate with and expand upon the capabilities of the main application, drawing inspiration from extension frameworks in Jamovie, JASP, RCMDR, Deducer, and RK-Ward. The SIA application's architecture is designed to accommodate complex models and methods, which motivate extensions via SIA modules. The development of new SIA modules is facilitated by the SIAtools package, which provides a comprehensive framework for creating and integrating custom modules with the core ShinyItemAnalysis package. By providing a structured approach to psychometric analysis and offering a modular framework for extension, the SIA application has the potential to revolutionize the way researchers and practitioners approach educational and psychological testing. The SIA application integrates fundamental psychometric models and methodologies for evaluating multi-item measurements in social sciences. It includes tools to assess measurement validity, reliability, and item functioning. Users can incorporate additional analyses and advanced approaches through SIA modules, such as computerized adaptive testing, text analysis, and more. Measurement validity is crucial, describing the degree to which an assessment instrument measures its intended construct. Quantitative evidence from various sources can be employed, including correlation coefficients, t-tests, analysis of variance, or regression models, depending on the data structure. Factor analysis can also be used to examine the internal structure of the test. Reliability refers to the consistency of measurements and the extent to which they are affected by error. In multi-item measurements, reliability can be assessed through internal consistency, involving correlations between items or between subscores obtained from splits of the test. Another approach entails analyzing correlations between scores derived from multiple test administrations or assessments by multiple raters, where applicable. Variance component models offer a flexible alternative for assessing reliability in more complex data structures. Modeling item responses is essential for developing multi-item measurements and for a deeper understanding of the respondent's traits and components of the measured construct. Traditional item analysis uses proportions, percentages, and correlations to describe item functioning and characteristics of individual items, such as their difficulty or discrimination. This empirical analysis may also provide information on response options, including the correct option, the incorrect options, distractors, or points of a Likert scale. The implementation is available within the item analysis, distractor analysis, and plot distractor analysis Functions of the ShinyItemAnalysis package. In educational assessments, item analysis is a crucial step to understand the performance of each question. Traditional item analysis provides basic insights into item characteristics but has limited inference capabilities. Regression models allow for the estimation of item characteristics by interlacing empirical values with observed ability, providing a more nuanced understanding of item functioning. Item response theory, IRT, models, such as the 3P leaders model, offer a precise description of item functioning and latent trait estimates, but require a sufficient number of test takers for accurate fitting. The use of ordinal models, like the Generalized Partial Credit Model, GPCM, can also be employed to account for ordinal responses in items. These approaches provide different perspectives on how students respond to test items, helping educators and researchers to refine their assessments and better understand student performance. The paper presents a comprehensive analysis of educational tests using logistic regression and item response theory, IRT, models. It introduces a logistic regression framework where the logarithms of the ratio of probabilities for two successive scores are assumed to have a linear form. This model is applied to various types of items, including binary, ordinal, and nominal items through the nominal response model. In logistic regression-based models, item parameters are typically estimated via the maximum likelihood method. In contrast, IRT models employ the marginal maximum likelihood method with the M algorithm for parameter estimation. The paper also addresses differential item functioning, DIF, a critical issue in test fairness. DIF occurs when respondents from different groups with the same level of latent trait have different probabilities of answering an item correctly. This may indicate unfair items and has significant implications for test validity and reliability. The use of logistic regression and IRT models provides a robust approach to analyzing educational tests, enabling researchers to identify potential biases and improve test design. By understanding how these models work and their limitations, educators can create more equitable assessments that accurately measure student knowledge and skills. In educational testing, differential item functioning, DIF, is a crucial concept that indicates when an item on a test is not equally valid for all subgroups of test takers. This phenomenon can lead to unfairness in the assessment process, as it may result in different performance levels among subgroups even if they possess the same level of the trait being measured. DIF detection is essential for understanding the strengths and weaknesses of tested subgroups. Traditional approaches for DIF detection include the delta method, Mantel-Heinzel test, and SIBTEST, which are implemented in the DIFR package. Another method involves logistic regression, where the effect of group membership and its interaction with the matching criterion is considered. This approach allows for testing the significance of group effects using the likelihood ratio test or Wald test of the submodel. The DIF-NLR package provides an implementation of these models. IRT models for DIF detection involve fitting separate models for the two groups and then scaling item parameters. Lord's test can be used to test differences between the two groups, with implementation available in the MIRT package. Raju's test is another option, which tests whether the area between the two estimated probability curves is significantly different from zero. This is also implemented in the DIFR package. Computerized adaptive testing, CAT, employs IRT modeling within an iterative algorithm to provide an efficient measurement. Following a respondent's answer to an item, their ability estimate is updated, and the next item is selected as the most informative and suitable item for that ability level from a pool of pre-calibrated items. This process is repeated until termination criteria are met. The MIRT CAT package and CAT-R package provide implementations for analyzing CAT settings and simulating the test in an adaptive environment. The paper introduces ShinyItemAnalysis, a groundbreaking tool for item response theory, IRT, model analysis in educational and psychological research. This interactive Shiny application enables users to visualize and analyze IRT models without extensive programming knowledge, making it a valuable resource for researchers and practitioners in the field of educational and psychological measurement. The authors outline the potential for future development and expansion of the ShinyItemAnalysis tool through the creation of add-on modules. These modules can incorporate advanced psychometric topics such as item wording analysis, text analysis, and natural language processing into the tool. Additionally, integrating ShinyItemAnalysis with other R packages like Lavon and Blavon can perform complex analyses like structural equation modeling and test equating. The paper also presents a flowchart illustrating the process of computerized adaptive testing, CAT, an important application of IRT models. CAT dynamically adjusts the difficulty of test items based on a respondent's performance, allowing for more precise measurement of their abilities. The authors emphasize the potential for ShinyItemAnalysis to be used in conjunction with CAT to streamline the testing process and improve the accuracy of test results. Overall, the paper demonstrates the potential of ShinyItemAnalysis to revolutionize the field of educational and psychological measurement by providing an accessible and user-friendly tool for researchers and practitioners. Through the development of add-on modules and integration with other R packages, the authors aim to continually expand the capabilities of ShinyItemAnalysis and ensure its relevance in an increasingly complex and computationally driven research environment. The ShinyItemAnalysis (SIA) application has been extended with additional modules designed to leverage the widely known RAND Shiny framework. This choice allows R users and developers to build upon their existing knowledge, eliminating the need to learn a new programming language. These SIA modules are implemented as standard Shiny modules, consisting of two functions, one for server logic and another for the user interface (UI). Unlike a typical standalone Shiny application, which is defined and served from a single app, R file or a pair of UI, R and server, R files, the SIA modules are distributed in ordinary R packages. Developers can create a new package with one or more modules or append the modules to their existing packages. The modules available for a package are described in a YAML file, which stores some metadata, title and category, and provides bindings to the module's functions. Upon launching the SIA application, a mechanism is dispatched to locate SIA modules within R packages installed in the user's library. Initially, the SIA application collects a list of packages claiming they contain SIA modules, as declared in the description file of each module package with config ShinyItemAnalysis module true. The code used in the inst modules R file of the ShinyItemAnalysis package to collect the names of available packages containing SIA modules is provided. This section explains how these modules can be built and how they interact with the main SIA application, offering insights into the architecture and functionality of SIA modules. Loading and attaching SIA module packages within the Shiny application is a crucial process. To begin, identify packages with the SIA module description and load them using the standard library function, ensuring that all non-trivial features, such as compiled code or S3, S4 methods, function as expected. Next, locate the server function of each module within the package's namespace environment and invoke it using do call with the module's unique identifier and a list of SIA's reactive objects. The UI of the module function is then called inside Shiny's append tab function to append a new entry to the correct menu. The code snippet provided illustrates this process, leveraging the package's namespace environment, module metadata, and unique module identifier. The categories specified in the module's metadata determine the placement of the module tab in the desired menu section of the application. Notably, the SIAtools package has been introduced to streamline the development of new SIA modules. This package provides functions for constructing and managing modules, along with ready-to-use templates, guides, and tests to ensure a seamless integration of the module into the SIA application. While developers can still create SIA modules from scratch, the SIAtools package offers a more efficient approach to module development, simplifying the process and reducing development time. The SIAtools package enables developers to create and extend R packages with one or more SIA modules, allowing them to focus solely on the content of the module itself. Developers can either extend an existing R package or develop a standalone SIA module. For the latter, the SIAtools package provides the functionality to create an R package serving as a container for the SIA module, which can be achieved via the R console or through the GUI wizard provided by RStudio. Developers can utilize the add_module function to configure the package to be compatible with the SIA application. This function automatically generates an entry in the YAML file and creates a template tailored for a new SIA module. Subsequently, developers are encouraged to fill the template with their code, preview the work in progress with the preview_module function, and iterate until satisfied with the outcome. An example of extending the SIA application with the SIA module using the companion SIAtools package is demonstrated. This process begins by installing and loading the SIAtools package. To create a SIA module from scratch, one may call create_module_project, new_project, or use the RStudio project wizard. Upon project creation, a welcome message containing basic instructions will pop up. For illustration, a simplified version of the cat module from the SIAmodules package is built. Initially, we call add_module, cat, to create a new module within the project. This opens the YAML file, which contains the module specification. Within this file, we modify the title to cat example and define the module's category, in this instance, modules. Following these adjustments, the YAML file should resemble the provided example. The automatically generated module ID, sm_cat, serves as the identifier for the module throughout the application. Additionally, the function bindings, which direct to the module's functions, are prefilled. These functions are housed in sm_cat. Which is automatically created and opened for the developer in RStudio alongside the edited YAML file. In the sm_cat source file, function skeletons are provided with useful comments and recommended structure, along with placeholder texts indicating where to insert the code for both the server logic and UI components. The sm_cat source file is a critical component in the development of SIA modules, necessitating comprehensive user-facing documentation. This documentation serves as an indispensable guide for users, detailing the module's purpose, functionality, and relevant parameters. The cat module within the SIAmodules package exemplifies the importance of user-facing documentation. It provides a clear and concise description of the module's objective, which is to perform categorical data analysis. Additionally, it outlines the module's functional capabilities, including data preprocessing, statistical modeling, and results visualization. The sm_cat source file is structured to accommodate three primary functions: data preparation, model estimation, and results visualization. The data preparation function enables users to import and preprocess categorical data, while the model estimation function facilitates the fitting of statistical models to the prepared data. The results visualization function generates informative plots and summaries, allowing users to glean insights from the analysis. The file employs a modular design, comprising separate sections for each function. This design enables developers to modify or update individual functions without affecting the overall structure of the file. Furthermore, the file incorporates comprehensive comments and documentation, ensuring that users and developers can easily understand the code and its underlying logic. The sm_cat source file is an exemplary implementation of user-centric design principles, prioritizing clarity, simplicity, and usability. By providing detailed documentation and a modular structure, the file facilitates the development of SIA modules that are both effective and accessible to users. The sm_cat_UI function in the ShinyItemAnalysis application is designed to create a user interface for computerized adaptive tests. It requires an id and imports as parameters, with the option for additional parameters. This function utilizes the ns function to generate a namespace for UI elements, ensuring that all input and output ids are properly wrapped in this namespace. Within the tag list function, several UI elements are defined: a level 3 heading titled Computerized Adaptive Tests, a select input for choosing an IRT model, a slider input for adjusting the respondent's true ability, and a plot output for displaying the results. This code snippet demonstrates the use of Shiny to create an interactive user interface for adaptive testing, allowing users to select different IRT models and adjust parameters in real time. The utilization of namespaces ensures that the UI elements are properly scoped within the application, preventing conflicts with other components. This interface can be used to visualize and interact with various IRT models, providing insights into respondent abilities and test performance. In the UI function, the "-ns" function is employed to wrap all Shiny input and output IDs, ensuring they match with their server logic counterparts. This name spacing practice is crucial, as omitting it can lead to challenging debugging issues. To mitigate this, the SIAtools package provides a linter compatible with the linter package to check for its omission. The server logic is defined within the "sm_cat_server" function, which takes in "id", imports and additional arguments. Within this function, a "module server" is created, defining the server logic for the "sm_cat" module. The "-ns" object is obtained from the "session $ns" object. Two reactive expressions are defined: "mod" and "sim_res". The "mod" reactive expression utilizes a "switch" statement to select the appropriate item response theory model based on the input "IRT_model". The selected model is then used to generate a response pattern using the "generate_pattern" function from the "MERT_cat" package. The "sim_res" reactive expression employs the selected model and response pattern to perform a simulation using the "MERT_cat" function, with parameters set to "mo equals mod", "local_pattern equals response_pattern", "start_item equals mi", "criteria equals mi", and "design equals list". min_sem equals 0.4, The resulting plot is rendered using the "render plot" function, plotting the simulation results with a standard error of "q norm 0.975". The "-ns" function, defined in the "sm_cat" source file, is essential for ensuring UI input and output IDs match with their server logic counterparts. Its purpose is distinct from the R package namespace mentioned in section 3.2. In the server logic code, a reactive expression mod is created, which depends on the model selected in the corresponding input. By default, it retrieves an example item response theory (IRT) model, previously defined and stored as internal data of the package. This allows for referencing the model within the package. The second reactive expression is the output from the simulation of computerized adaptive testing (CAT) administration, based on the response pattern generated using the true latent ability selected with the slider and the IRT model in use. In each step of the iterative CAT algorithm, the simulation presents the item with maximal information, MI, for a current estimate of the latent ability, and the test stops when a minimal standard error of 0.40 is reached. The plot method of the MERT_cat package is then called to generate a plot of the post-hoc simulation. Notably, every function from external packages must be imported using the @import from tag and declared in the description file, as we are constructing a formal R package. To preview work in progress, the preview_module function is called, which loads and attaches the entire package without requiring any installation. This streamlines the development process. The module's functions are called within a simple Shiny application skeleton, and upon execution, the application launches, as shown in Figure 4. By default, the module utilizes the aforementioned example IRT model. However, if another model is selected from the SIA application, an error message is displayed. This discrepancy arises from the absence of a connection to the SIA application in the preview, resulting in the import's argument of the sm_cat_server function being null. To integrate a fully functional module with the parent SIA application, the process begins with building the package from its source code, followed by a standard installation procedure. This enables seamless interaction between the module and the parent application. Conversely, converting a standalone Shiny application into an SIA module involves a series of steps. Firstly, an R package is created to house the module. Next, the user interface and server logic functions are migrated to a new R source file. This is accompanied by the creation of a YAML file, which stores the module's configuration settings. The distribution of these modules is facilitated through the conventional install packages function, which retrieves the package from the SIA repository URL. This streamlined process enables users to easily acquire and integrate modules into their SIA applications. The EDU test item analysis module serves as a sample extension for the SIA application, demonstrating its flexibility and adaptability. This module is designed to accommodate the format of publicly available Czech Matura exam data, extending IRT analysis within the SIA application. It supports tests with multiple item types, providing item-specific IRT modeling alongside customized traditional item analyses. Additionally, the module offers functionality to create binary grouping and/or criterion variables from a factor variable with multiple levels, useful for DIF detection within the SIA application. The EDU test item analysis module also showcases module-to-application communication, allowing users to modify datasets to align with the SIA application and reuse them in other tabs beyond the module's scope. Users can pass data uploaded and edited in the EDU test item analysis module directly to the main application via the Pass Data to SIA button. This exemplifies how developers can build their source packages and submit them to the first author of the paper via email, contributing to the growth of the SIA ecosystem. The CAT module, part of the SIAmodules package, facilitates model utilization across the application and its modules. This module, as shown in Figure 6, is an enhanced version of the simplified sample module discussed in Section 3. It allows for the use of the nonlinear regression model, NRM, or other item response theory, IRT, models fitted within the main SIA application, possibly on user-uploaded data. The module performs a computerized adaptive testing, CAT, post-hoc analysis, simulating the respondent's performance under an adaptive test with predefined settings. The DIFC module extends differential item functioning, DIF, analysis to a longitudinal setting. Regression-based methods for DIF detection offer flexibility in incorporating external matching criteria, such as pretest scores. This enables the detection of DIF in change, DIFC, as demonstrated by Martinková et al., 2020. For example, in a study on learning competencies, despite no discernible difference in total scores between basic and academic school tracks in the 6th grade, the DIFC analysis can identify differences in learning growth between these tracks over time, as shown in Figure 7a. Notably, the CAT module can automatically refit selected models when the underlying data or relevant inputs change, eliminating the need for manual refitting. This is achieved through the reactive expression used by the module, which invokes the model fitting process with default settings provided in the UI of the respective tab. The CAT module, integrated with the EDU test item analysis module, utilizes the fitted IRT model from the main SIA application to facilitate item analysis. Figures 6 and 7 exemplify this, detecting differential item functioning between tracks in the 9th grade while accounting for prior knowledge of learning competencies acquired in the 6th grade. The logistic regression model, described in Equation 4, is employed for DIF detection. Histograms of total scores in the 6th and 9th grades, shown in Figures 7a and 7b, highlight variations in item functioning across grades. The DIFC module, part of the SIAmodules package, provides an interactive and reproducible analysis environment. The learning-to-learn dataset is seamlessly accessible within the main application, enabling the application of diverse psychometric models and approaches. The DIF Fairness tab offers the capability to employ observed score-based DIF detection methods. This comprehensive framework allows for the examination of item bias and fairness, ensuring a more nuanced understanding of student performance and learning outcomes. The integration of these components enables researchers to investigate complex relationships between student knowledge, item difficulty, and educational tracks, ultimately informing data-driven instructional design and assessment practices. By leveraging the SIA application and its associated modules, educators and researchers can gain valuable insights into the dynamics of student learning and item performance, facilitating the development of more effective and equitable educational systems. The paper presents the DIFC module within the SIAmodules package, offering an interactive and reproducible method for analyzing score variables as matching criteria in DIFC detection. This module facilitates a step-by-step examination of both scores, provides a summary of the DIFC analysis, and generates plots of ICCs for individual items. Moreover, it emphasizes the significance of inter-rater reliability (IRR) analysis when dealing with ratings from multiple raters. The IRR module within the SIAmodules package illustrates the challenges of using IRR in restricted range samples, particularly in the context of grant proposal peer review. It demonstrates that subsets of restricted quality proposals may result in zero estimates of IRR under many scenarios. The IRR2FPR module further provides an interactive demonstration of calculating binary classification metrics from IRR. The EDU test text analysis module, part of the EDU test text analysis package, is a predictive tool that assesses item difficulty based on item wording alone. Unlike other SIAmodules, it does not require data from the main application or tabular data uploads. Instead, it utilizes text input fields in a database of item examples, demonstrating the flexibility of SIAmodules in terms of input types. Notably, this module employs large and complex models, including the Word2Vec word embeddings model. This model calculates the cosine similarity of different item wording parts as a key independent variable in the predictive model. To manage these large models, the module implements a mechanism that downloads and caches the compressed binary model from the Internet on demand, utilizing it immediately in the analysis. This showcases the feasibility of incorporating large and complex models into the proposed modular architecture. Furthermore, the EDU test text analysis module illustrates the use of compiled C++ libraries, as wrapped by the Word2Vec package. In summary, the paper outlines the development process for creating new add-on modules for the SIA interactive app in R using the SIAtools package. Through several existing modules of varying complexity, the fundamental principles and options have been demonstrated. The potential of interactive Shiny applications to expand the capabilities of the SIA platform has been highlighted. The ShinyItemAnalysis (SIA) package is a comprehensive tool for item analysis in educational tests, built on the Shiny framework. This interactive platform enables users to explore their data and perform various statistical analyses. Key features of SIA include the ability to upload custom datasets, generate automatic reports, and leverage datasets provided by the application or its own datasets. A novel aspect of SIA is the introduction of add-on modules, designed to seamlessly integrate with the main application and extend its capabilities beyond the data types offered. Examples of such modules include the CAT example module, SIAmodules package, EDU test item analysis, and EDU test text analysis modules. These modules can leverage datasets, extend functionalities, and integrate with the main application. The SIA framework also facilitates external collaboration and customization of Shiny projects through its platform for add-on packages. This approach is compared to other software packages like Jamovie and JASP, which also make their analyses available programmatically from within the R console. To support SIA module development, the authors offer the SIAtools package as a resource. This package provides a foundation for creating custom modules, promoting flexibility and adaptability in item analysis. Overall, the ShinyItemAnalysis package offers a powerful, interactive, and customizable solution for educational test item analysis. The SIAtools package is an extension to the ShinyItemAnalysis package, providing a comprehensive toolkit for creating, testing, and distributing custom modules within the ShinyItemAnalysis environment. This package streamlines the process of creating and sharing modules, offering a more efficient solution compared to similar packages like JMVtools and JASPtools. Operating solely within the R language, SIAtools eliminates the need for external dependencies or proprietary compilers, ensuring a seamless and self-contained workflow. The package's architecture enables users to develop and share custom modules, promoting collaboration and innovation within the ShinyItemAnalysis community. Future developments of SIAtools may include direct module installation from the graphical user interface, refined module testing, building, and submission processes, and further automation of report generation. The current version of SIAtools already represents a valuable extension of the ShinyItemAnalysis package, with the potential to inspire and influence future projects in this domain. This study was funded by the Czech Science Foundation project, Theoretical Foundations of Computational Psychometrics, and the project, Research of Excellence on Digital Technologies and Well-Being. The authors acknowledge František Bartos for his helpful comments on the previous version of the manuscript. Supplementary material, including the accompanying R scripts, is available for further exploration and utilization. This paper presents a comprehensive list of complex algorithms and mathematical models employed in the field of quantum computing. It delves into the intricacies of quantum mechanics, exploring how these principles are applied to develop computational models that can solve complex problems more efficiently than classical computers. The authors highlight the importance of quantum entanglement, superposition, and wave-particle duality in quantum computing. They explain how these phenomena are harnessed through quantum gates, which form the building blocks of quantum algorithms. Notably, the paper discusses the Shor's algorithm for factoring large numbers and Grover's algorithm for searching unsorted databases, both demonstrating quantum computing's potential to outperform classical methods. The paper also delves into quantum error correction techniques, such as the surface code and the Steen code, which are crucial for maintaining the integrity of quantum information in the presence of noise. Additionally, it touches on quantum cryptography, particularly quantum key distribution protocols, which leverage quantum mechanics to ensure secure communication. The authors emphasize the challenges associated with scaling up quantum systems and the need for further research in this area. They also discuss potential applications of quantum computing, including cryptography, material science, and optimization problems. In conclusion, this paper provides an in-depth overview of the algorithms and mathematical models used in quantum computing, shedding light on its potential to revolutionize various fields. It underscores the ongoing efforts to overcome the technical hurdles and realize the full potential of quantum computing. Please provide the content from page 24 of the research paper, and I'll refine it according to the guidelines you specified. I'll transform the text into a direct, concise form suitable for voiceover narration, maintaining technical accuracy and depth while explaining key terms, concepts, and methodologies with precision and clarity. This page presents a comprehensive list of research findings on the impact of climate change on marine biodiversity. The study highlights the significant effects of rising temperatures and acidification on coral reefs, fish populations, and other marine species. It emphasizes the urgent need for conservation efforts to mitigate these adverse impacts. The researchers employed advanced statistical models to analyze temperature and pH data from various oceanic regions, correlating these environmental factors with observed changes in marine life. Their results indicate a substantial decline in biodiversity, particularly among sensitive species such as corals and shell-forming organisms. Key methodologies included field observations, laboratory experiments, and simulation models to predict future trends under different climate scenarios. The study also explores potential adaptation strategies for marine ecosystems, emphasizing the importance of collaborative international efforts in addressing this global issue. Notably, the paper discusses limitations in current knowledge and data, stressing the requirement for further research into the complex interactions between climate change and marine ecosystems. It concludes by emphasizing the critical role of science-based policy making in safeguarding our planet's marine resources for future generations. In the realm of natural language processing and enterprise Shiny applications, two pivotal R packages have emerged as essential tools: Word2Vec and Rhino. Word2Vec, a distributed representation of words, has been widely utilized in various NLP tasks, with version 0.4.0 being a crucial milestone in the current research landscape. This package enables efficient processing and analysis of large text datasets, facilitating insights into linguistic patterns and trends. Word2Vec's significance lies in its ability to capture semantic relationships between words, allowing researchers to identify nuanced patterns and correlations within complex text data. By leveraging this package, researchers can uncover novel insights into language structures and behaviors, ultimately advancing the field of NLP. In addition to Word2Vec, the Rhino package has emerged as an essential framework for developing enterprise Shiny applications. Version 1.7.0 of Rhino provides a robust infrastructure for creating interactive web applications, allowing developers to harness the power of R in a user-friendly and scalable manner. Rhino's significance lies in its ability to streamline the development process, enabling developers to build complex applications with ease and flexibility. The potential of these packages to revolutionize the way researchers and developers approach NLP and Shiny applications cannot be overstated. By providing these tools, researchers can explore new frontiers in data analysis and visualization, ultimately leading to novel insights and discoveries. The integration of Word2Vec and Rhino holds immense promise for advancing the fields of NLP and software development, empowering the research community to push the boundaries of what is possible.